Ever since Leica started selling its first camera in 1925, its preferred method for focusing the camera has always been this thing, the rangefinder. It's a precise method for manually focusing the camera since, they didn't have autofocus in 1925. So Leica's rangefinder originally started as this separate attachment that went on top of the camera body and eventually got more and more integrated into the camera itself. But the mechanics for how it focuses has remained the same for pretty much the last 100 years. But now Leica's trying something different with what it's deeming an all-new camera line. This is the Leica M EV1, a Leica M body that ditches the traditional rangefinder and replaces it with an electronic viewfinder. So okay, yeah, in one sense, this is a really freaking simple change, right? They're just taking the electronic viewfinder from the Leica Q3, its full-frame, fixed-lens, autofocus-capable camera, and they're smashing that into the Leica M11, its flagship camera. And I'm not going to sit here and pretend that an electronic viewfinder is some innovative new feature, right? I mean, we've had EVFs for a really long time. But I think the reasons why Leica is doing this are a little more complex. And I think to fully understand those reasons, it's kind of important to understand how rangefinders even work in the first place. Okay, so a rangefinder does exactly what it says it does. It finds the range between you and your subject. These things have been used for a really long time and are even used in sports like golf. But they actually date way back to 1771 when they were used for surveying canals. But the reason they're important to photography is because lenses focus by moving big pieces of glass back and forth, and knowing exactly how far you are from your subject is very important to nailing your shot. So the rangefinder on a Leica camera has over 100 pieces that make it work, but it actually utilizes a really simple rule from trigonometry called triangulation. That is, if you know the distance and angle between 2 points on a triangle, you can actually know the exact distance between that third point on the triangle. This is also the system that allows our eyes to interpolate depth in 3D space. So on a rangefinder camera, you've got two distinct windows that say a very different angle of the scene. And because we know the distance between those two windows too, you can interpolate the distance to the subject. Let's break that down. Okay, so on one side of the camera, you've got the viewfinder. This is pretty much just a piece of glass that lets you look through it to view your scene. But it turns out you're not just looking through that piece of glass. You're also looking through something called a beam splitter, which is a semi-transparent piece of glass which is treated with a semi-reflective coating, which will reflect some light, which we'll get to in a sec. Okay, so on the other side of the camera, you've got the rangefinder window. This window takes a very slightly different perspective of the scene and bounces that light around a series of prisms. So that light then gets projected through an extra lens, which can actually move to change the angle of the beam when you change the focus of the lens. Then the light passes through this small hole in a mirror, then through a small hole in a mask. That's called the rangefinder patch. That mask with the rangefinder patch on it also has frame lines that get illuminated from an LED that bounces off that mirror. Then all of that light passes through another series of lenses where it gets magnified, bounces off that beam splitter, and back into your eye so you can see it superimposed in the viewfinder. When you change focus on any M-mount lens, a gear pushes the arm of the rangefinder assembly, which pivots the internal lens and shifts where that rangefinder patch is. When the scene from the viewfinder and the rangefinder patch line up, that's how you know you're in focus. And that is how rangefinders work. It's a pretty simple mathematical system with a pretty complex implementation, but it's a cool mechanism. Because you're just seeing through the viewfinder, you can wait for the perfect moment before you take your shot, and because those frame lines barely use any power, these cameras tend to have a lot of battery life. So then, if the rangefinder is so great, why would Leica get rid of it with the M EV1? Well, let me show you a graph. So as of December 2023, the largest digital camera manufacturer wasn't Leica, it was Canon. The second largest wasn't Leica either. It was Sony. The third was Nikon, then Fujifilm, then Panasonic. Then in this little sliver, you've got other, which includes a lot of small manufacturers, including Leica somewhere in there. Now, obviously, a big reason for this is that Leica's cameras are generally very expensive. Its flagship M11P costs almost $10,000, and the Leica Q3 cost about $6,700 after tariffs. These aren't just cameras that anyone can go out and buy. But if you look at this press release that Leica put out last month, there are some key lines. The Leica Q3 was the biggest seller among the company's digital cameras. The full-frame system cameras, Leica SL3 and SL3S, were also in high demand. A small compact camera was added to the range in the form of the Leica Deluxe 8. For the M system, Leica launched the M11D, a variant of the iconic full-frame digital camera that dispenses with a digital display. I think those two sections kind of say a lot, right? Leica's digital cameras with electronic viewfinders and autofocus sold very well. We don't actually know how well the M11 sold for Leica. It doesn't release that sales data, but we do know that this is its iconic camera, right? Leica really doesn't want it to get left behind. But the reality is, if you're going to invest in a $10,000-ish system, it's kind of a hard sell to get someone to try to get used to a type of focusing that you're just not used to and has a lot of limitations that other cameras just don't have. For example, the M11 can only show focus up to zero point 0.7 meters because of that same trigonometry that I talked about earlier. The closer you get to your subject, the more extreme the rate of change on the angle of the hypotenuse of that triangle. That means that internal focusing lens on the inside of the rangefinder is going to have to turn a lot faster for a slight change of the lens focus. And you can actually see that on the lens itself. Like, see how much you have to turn the lens to move from 0.7 to 0.8 meters, then to 1 meter? Then pretty quickly, the same amount of change on that lens moves to 2 meters, 3 meters, 5 meters, 10 meters, and then infinity. That's because of that same math. And because the parallax between what the viewfinder sees and what the lens sees gets worse the closer you get to your subject, I think Leica thought that 0.7 meters was a good middle ground. It's just really hard to focus a macro lens on a rangefinder camera. Also, if you're shooting a lens with a really wide aperture like f1.2 or something, it's really hard to make sure you hit critical focus with that lens because you can't punch into the image or anything like that. And also, cameras like the M11 have frame lines for 28mm, 35mm, 50, 75, 90, and 135, which are some of the most common focal lengths that you're going to see. But if you use anything outside of that range or between those ranges, you're going to have to use a separate viewfinder, which just kind of sucks. Now, yeah, it is super gratifying to hit a shot with a rangefinder camera that you weren't really sure if you were going to hit. That just feels good. But this can be a lot of trade-offs for someone just to get something with really deep heritage and pretty cool physics. So if Leica wants to see growth in its M-body line and it also wants to see general market growth overall, what does it do? Well, one option is to try this, make the Leica M EV1. Now, I would have loved if they just split the difference and made a hybrid optical viewfinder like Fujifilm does with the X Pro 3 and the X100 line. But Fujifilm has that patented until at least 2028, so it's probably going to be a while before Leica can do something like that. But at least for now, I think that Leica's just kind of testing the water with this thing, seeing how it sells and moving on from there. I think there's a reason they didn't call it the Leica M11 EV1, because they don't want the pressure of making a version like this every single generation if it doesn't do well. But at least if it doesn't sell, they can just use it as an opportunity to use up extra M11 and Q3 parts. Now, Leica did add a couple extra features for getting rid of the rangefinder window, though. Like, for example, this switch used to be used to manually swap out the frame lines, but now it's a remappable switch, so you can change it to things like focus peaking or critical focus check. So I'm glad that they're actually using these old body parts. And getting rid of that complex mechanism means that they can sell it for a little bit less. At least in the US, this camera is $845 cheaper than the M11P, though it does only have 64 gigabytes of storage internally and the standard glass on the back instead of that sapphire glass, so not quite as good. So that's been it for this camera. I hope you guys found that useful. Maybe you're more interested in rangefinders, or maybe you're less interested in rangefinders now. For what it's worth, all my favorite film cameras are rangefinders, so there's that. But anyway, I'll see you guys next time I got something to say. See you later.